So in this video, I'm going to be showing you how to code an airdrop app whereby users can be able to claim their airdrop. And for you to be able to claim an airdrop, you need to be a holder of this token. You need to hold a certain percent of a token to be able to claim the reward token. So you need to hold a certain percent of this whole token to be able to claim the reward token. So if you are not new to DeFi, you must have seen a lot of projects do this kind of airdrops. So sort of reward. So let's go. So we are going to be coding the airdrop app now. So we're going to do our pragma. I'm going to do a version greater than 0.8.18 so that it will grab the latest version of Solidity for us. So we're going to do a contract. No, before we do our contract, we're going to define our interface, our IRC20 token interface. So we're going to do an interface. It's going to be IARC20. Alright. Then it's going to take in two functions because we're going to be using two functions. We're going to be using balance of and the transfer. So we're going to do a function. Balance of. So this is going to be taking an address type. Address is going to be address account, balance of the account. So it's going to be an external. Then it's going to be view. Then it's going to be returning the balance of our users, which is going to be in U256. So we're going to do so every function in an interface ends with a semicolon. So we're going to do another function, which is going to be our transfer. So we're going to do a transfer. So it's going to be taking an address to, then it's going to be taking a U256 amount. Then it's going to be an external. It's going to be return bool. So it's going to return success, whether the transaction went or failed. So our interface is okay. So we're going to do another interface. I like to use custom errors. So all my errors is going to be in this errors interface. So we are not going to be having anything here. So we're going to do our contracts. So which is going to be the airdrop contract. So it's going to be airdrop. Then we're going to be inheriting from these errors. So that any error we put here, we can be able to use it in this contract. So we don't need to inherit from this IARC20 contract interface. Interface is not a contract, please mind you. So it's errors. So anything we declare here is going to be part of this. So we're going to do a U256. And note, we always want to make our contract as gas efficient as possible. So that's why we're using our custom errors. So we are going to be using a U256. So we're going to be the claim fee. So it's going to be public, right? It's going to be constant variable because we are going to be declaring this from here. And because we want our variables to be less gas efficient, as you know, constant variables and immutable variable are less likely to cause much gas. So we're going to be using 256 public constant. It's going to be taken in we're going to be naming this claim fee. It's going to be in caps lock. So I put it in caps lock so that we know our constant variables from our other variables. Claim fee, which is going to be 0.005 ether. Then we declare another variable event 256 public constant. Another reason why it's constant because we are not going to be changing these values. Claim amount So the amount that is going to be dropped to users is going to be equals to we're going to be dropping 2000. Let's say we're going to be dropping 2000 zeros, 2000 tokens. So multiply by 10 raised to power 18 zeros. So we are adding the decimal, so we don't need to do much calculation in our claim contracts, in our claim function. So we're going to do an address. Address also is going to be public. This time around is going to be immutable because we are not going to be setting it from outside the contract. We're going to be using our constructor to update this address. So we're going to be using immutable. So immutable is just like constant. You can't change it once you declared it. So it's going to be an owner. Yeah. So right. So we're going to do for the two we're going to be storing the instance for the two contracts, the hold token, the token that users must hold before they are able to claim this airdrop, and the reward token. So we are going to do IARC 20. It's going to be public. Then it's going to be it's going to be immutable because we are not declaring it from here. So it's going to be hold token. Then another IRC. So we just do control. So we just do shift alternate down to just make a copy of this below. So it's going to be let's just name this RWD reward. I will just do a reward token. Okay. So I think we are done with our so next we're going to declare our constructor. So it's going to be constructor. This is going to be it's going to be taken into variables, which is the hold token and the reward token. So it's going to be address, then hold token, then secondly it's going to take in another address. This is going to be reward. You can see I'm using an underscore to differentiate between this and this, so they are different things, please. So it's going to be we're going to be doing hold token is equals to we're going to wrap it around the IALC 20 to convert it to a constant instance. So convert it to a contract instance. So we're going to do a hold token. Yeah. Then we're going to do a reward. So reward token is equals to same we did here, IALC 20. So wrap it. And we do the reward token. This is the reward token. So and then lastly, IALC here. So lastly, what we're going to do is we're going to assign the message or sender to the owner. So we're going to do owner. Owner is going to be message or sender. So anybody that deploys this contract is going to be the owner. So we don't need to emphasize much on that. So so we're going to do a function. We're going to do the function claim. A function claim. This function is going to be public. It's going to be payable because we are going to be sending ether. If you don't have enough ether, you can't claim this. So okay. So we did it. So we want we want that we're going to require that anybody that claims this contract the amount they are sending must be equal to the exact claim fee. So how we are going to do that? We are going to do it in two ways. We're going to use our require keyword, and we're going to use our custom errors. So we do require um require do message dot value is a global variable that stores the ether sent with a contract call, with a function call, sorry, rather, must be equals to claim fee. So if it's not equals to claim fee, we'll do invalid amount of ether, invalid amount sent, invalid, or rather invalid fee amount. Let's just do it at this invalid fee amount, right? So okay. So let's go and test this and see. Let's see if it's working. I know I'm going to have an issue with my remix VM. So first thing, we're going to deploy the two token. So we deploy the whole token. I know it's failing because I'm having a hard time getting the correct remix VM. Okay, so whole token was deployed, reward token will transact. So reward token was deployed, so we are going to pass in the instance like we said in our constructor. It's going to take in the instance of this, right? We're going to paste it here and taking the instance of the other one, so we're going to paste it here. So we're going to hit transact. Our contract is going to be deployed successfully. You can see airdrop, you can see claim fee, claim amounts, whole token owner, then you can see the reward token. So we just wanted to test our claim to see if our required statement works perfectly. So let's send let's send 100 way, which is not up to this amount. So let's see if our claim function will work. You can see it failed, invalid amount. So our required statement is working perfectly. So let's see what we can do. So we don't want to use this required statement because I feel like I like using my custom errors. So we're going to spice things up a little bit. We're going to take out this. So we are going to do custom errors. So we're going to do error. To go to our interface, we're going to do error. Then we do with our error parameters, our error, what we want our error to pass in if it fails. So we're going to do invalid fee amount. So we declared our error here, invalid fee amount. So we are going to do, let's take, okay, we commented this out. We're going to do if message of value is not message dot value is not equals to claim fee. This time around we are saying if contract, if this message of value ether sent to this claim, if it's not equals to the claim amount, then revert. You fail, revert. After reverting, you throw this error, invalid fee amount, invalid fee amount. Did I get my spelling correctly? Oh, they're all in capital letter. Supposed to be small. Valid fee. So amount is going to be amount. Right? We got it right? So if message of value is not claim fee, We throw an error. This is what it's simply saying. And we won't test this out because of time. You just know that it works. So instead of putting this looking all bulky, we can just do a modifier. We do a modifier. So this modifier is going to take in uh, let's do claim fee. Let's call this modifier claim fee. So we're going to be taking this statement here, and we're going to be placing it inside our modifier. So placing it inside our modifier, we just stop this, then you can see. So insert it here, claim fee. So this claim fee modifier does the same thing as checking if the amount of data was sent correctly. So why we added the modifier to our function, so that once we hit this claim fee, this modifier will run first before any code in the claim, right? So we're going to do another modifier again. This time around, this modifier is going to be only owner modifier, only owner. It's only owner. So we're going to do another error. We're going to do not owner. So we're going to do if the person calling this function, if the person calling any function that we attach this only owner, we do if the message dot sender is not equals to owner, right? It's not equals to owner. Then we revert, we'll fill the function, then we'll throw this not owner. So not underscore owner. So then we continue. We continue our code, right? So if any function we attach this only owner to, only us, the message or sender, the owner of the contract, can be able to call it. So we can't attach it to this claim contract because it's accessible to everybody so long as you have the claim fee. So what else are we going to do? So we're going to event. So I'm going to do the event claimed. So address is going to take in claimer, then UINT 256 is going to take in the amount claimed, right? So we're going to be logging this event at the end of our function claim. So okay, so once we call the claim function, so we're going to be writing to our function. So since we did it checks if the correct enter was sent to the contract. Once the correct enter is sent to the contract, then we do a RWD. Sorry. So do reward token dot transfer. So I'm going to be transferring um transfer to the message or sender dot sender, then claim amount. Right? So we are calling the transfer function from this transfer since we wrapped it in the IRC20. So it automatically is a contract instance. So we are calling the reward token dot transfer. So we are transferring now two is the message or sender, then the claim amount is the amount to be transferred. So after we transfer, then what are we going to do next? Then we are going to log out. We are going to log our claim. We're going to do an emit. We're going to do our emit claimed. So this emit claim is going to be taken in the message or sender, the sender, which is the claimer, then the amount claimed, which is the claim amount. So you can see. So I think we are forgetting something. So we need to do a require statement. This time around, we're going to be doing a require statement because it's a crucial require statement. So why this this contract should be able to check, right? Should be able to check the balance of the message or sender, this person that is calling this function. If the person does not have enough balance, then this claim function is going to fail. So we're going to do require. We're going to do hold token dot balance of the balance of message dot sender. You can see must be greater than, okay, we want the person to have, okay, like at least 1000 token. So must be greater than. So let's not hard code 1000. So we're going to declare a uint 256. We're going to name this eligible balance is equals to, let's say we need the person to have at least 1000 token multiplied by 10 raised to power 18. So we want the person to have at least 1000 token of our hold token, the token to hold. So must be greater than eligible balance. So require hold token dot balance of. We're checking the balance of the message or sender. If he has more than eligible balance, then we'll deduct. He can go ahead and claim the reward. So require hold token dot balance of message or sender must be greater than or equals to eligible balance. Or else let's throw the error not eligible, right? So once you hit the claim function, it's going to check if the message or value, the ether that you are using to claim this fee, is equals to the claim fee. Then after that, it's going to check if you have enough, if you are holding up to 1000 token of the hold token. Then after checking if you have enough, then it's going to transfer some reward token to you, the message of sender. So we are going to be emitting the action. So we're going to deploy and see if our contract is working. So we already have our reward and hold and reward token. So we're just going to delete the airdrop token and we're going to deploy it again. So we're going to be taking two parameters, hold token, and the reward token. So I'm going to be pasting it here. Then after that, we're going to hit transact. And first thing, the contract. This airdrop token must have enough reward token. So we're going to be transferring some bonds to the airdrop contract so that it can disperse the token. So we are going to hit the transfer address to we're transferring to the contract. So let's say we are going to transfer. Let's just transfer all the token 1, 2, 3, 4, 5, 6, 7, 8. You can see the transaction went successfully. So let's check the balance of the contract. You can see. Okay. So we're going to be claiming with this first address. Since the address has some token, let's see, let's say the address has some hold token. So you can see we have some hold token. So we are holding the hold token. So we already passed this claim fee modifier. So let's go and claim. So all we have to do now is to send some ether. So we are going to take in the claim fee copy. Then I'm going to pass in the value here to paste it in. Then we are going to claim. You can see we claimed successfully and the ether was sent to the contract. So let's check our balance if we got the token successfully. So let's check our reward token. Let's check our balance here. Okay, you can see we got it. We got the balance of 2000 token. So you can see. So let's use another account. So let's check if we are eligible or not. So let's see how many hold token this token has. So we currently have 0 hold token. So we are going to see if we can be able to claim even though we are not holding the hold token. So we are going to be passing in this. We're going to pass in the claim fee. So we are claiming with an account which is not eligible for the claim. So we're going to claim. You can see even though we had enough data, the contract failed, not eligible. You can see we are not eligible for the airdrop because we are not holding any hold token. So let me transfer some hold token to the second account so to make it eligible. So we're going to be transferring 1000 token. And transfer 1000 token. 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So transferred 1000. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Why are we not having enough balance? Okay, that's because we're calling it from the second contract. Okay, so let's see if this goes successfully. So okay, you can see. So now we are now having some balance of the hold token. So let's see, let's try and claim. Now we are now eligible to claim some reward token. So let's take the claim thing. We paste it here. Let's try and claim. Invalid fee amount. Sorry, let's try passing the correct value. Control V. So let's try and claim. You can see we claimed successfully. So let's see if we have some reward token now. So we can see we have some reward token. So there's a problem here. We don't want we don't want them to be able to claim more than once. We want everybody to be able to claim only once, because if you look at this, we can claim more than once. Let me try and claim again so that you see what I'm talking about. So long as we have enough data, we keep claiming, and we don't want users to always keep spamming because we have limited supply. So let's try and claim. You can see we're able to claim again. So we don't want that. So we are going to define a mapping. So this mapping, we're going to declare it here. So this mapping keeps tracks of whether an address have claim or not. So we're going to do mapping. We're going to do address equals to bool. Then this is going to be public, whether public or private doesn't matter. So it's going to be has claimed. So in this require statement, we are going to do a modifier has claimed. So we're going to give an error cannot claim twice. So I'm going to do a modifier. So we're going to name this. And what are we going to name it? Has already claimed. Let's just name it has already claimed. Already claimed. So we're going to do if that has already claimed, which is a mapping of message or sender, has already claimed of message or sender, if the message of sender is true. We can actually leave it like this. We can actually do is true, or we just leave it like this. This is also true. So if has claimed message or sender is true, then we're going to throw this error. Cannot claim twice. So we're going to add it here. Has already claimed. So we add the modifier here. So after it claims, then we want to update. After the reward token was transferred to the message on sender, we want to update the modifier, the mapping has claimed. So we are going to do has claimed in message or sender dot sender will now be equals to true. Now be equals to true. So we've updated. Once we claim, we'll update this state to true. So once you try to click again, since it's already true, we can't claim again. So every user is entitled to claim only once. So let's try and test that function out. So I'm actually going to deploy the reward token again. So we'll deploy the reward. After deploying the reward, then we'll deploy our airdrop. We're going to copy code, then reward. So I'm going to transact. So let's try and claim. So we just take the claim fee, then we just copy it. Now we try to claim. Let's try and claim. We're using the address that has hold token, the address that is holding some token. So we just impute the amount here, claim fee. Then we try to claim. What did you say this time around? Okay, we need to send some ether to airdrop. We need to send some reward token to the. I don't know, we're always forgetting. So send 1 million to 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 16, 18. Are we sending more than? I think we're sending more than. So, okay, so we send some reward token so that the contract will be able to distribute the tokens. So, now we're going to do. So we're going to pass in the. Let's go and copy the fee so that we'll be able to claim. And even where we're using, like, we're connected to MetaMask, we won't be able to, will not be going to impute this value. MetaMask will just impute the value automatically. But since we're using our local console, we have to be imputing that fee there. So you can see I claimed. So let's try and claim again. As being a greedy person, trying to claim again. So you can see cannot claim twice, so the function works perfectly. So after all this ether have been accumulated, we want to withdraw. We want to withdraw the ether. So we do a function withdraw. So this function withdraw is going to be public. Then it's going to be only owner because we only want the owner to access this. So we're going to require that. Let's do a U2 fixes. We name this contract balance. So one that the contract balance just to address this. You now know the address. This is the contract. So this is the balance. This contract balance stores the balance of the address of this contract. So we're going to do that. The contract balance must be greater than 0. If not, throw the error insufficient amount. To withdraw. Or use sufficient balance to withdraw anyone. We just do anyone. So okay. So we're going to protect our withdrawal from reentrancy. So we're going to be declaring the bool here. Just declare bool. Sorry. So bool is locked. So this is false by default. So bool locked. So we're going to do a bool here. We're going to do another require that must not be locked, or else we entrance call if it is not locked, then we run the following code below. But if it is locked, then you call this, you try error and give this reentrance call. This reentrance call is like telling us, okay, our contract is about to be our contract was attacked, so it will try and error and protect it from reentrance call. So we're going to do our locked equals to true. So once we do our locked equals to true, anybody trying to do any reentrance call will see that, okay, this line of code is running, we are trying to withdraw. So in between the locked, we are going to do a locked equals to false. So any code we are going to be coding here is going to be protected. What this locked does is that once you call this withdraw function, it is going to be locked. The function is going to be locked. Nobody can call it why the function is being processing. So after it has processed all the withdrawal, then it will now be changed to false, unlocked. So why the locked is true, anybody trying to call this, you can see it will revert giving this entrance call. So they cannot call this thing twice simultaneously. So here we're going to do bool. We're going to use a low level function called to withdraw. So we're going to do a bool success. Here we're supposed to expect a byte type, whatever. But since we are not including that byte, we'll just do a command to tell Solidity that, hey, there was something that was supposed to be here, but we are going to ignore it. So it's going to be equals payable. So we are converting the address type to payable owner dot call. So it's going to take in this brackets, it's going to be taking in the value. So it's going to be taking a value which is going to be the contract balance. Then because normally this dot call was supposed to take in a string, because this we are calling this withdraw, we are going to be passing in a value. We are sending it out with a value, but since we are not sending any value, we just leave it as blank. So we're going to do a require success, or else we do a call failed. Sure. So we're going to do another event. This is going to be withdraw withdrawal. So withdrawal is going to be the owner, is going to be taking address owner, then amount withdraw with gone. I think I got it correctly. Gone. So we're going to be emitting after the locked is turned on to false. We're going to emit withdrawn owner, then contract balance. So only owner can call this function. So I think our contract is ready. So we're going to deploy one more time. So we deploy the app reward. And after deploying the reward, I will deploy airdrop using taking into parameters. Let's take in the hold token. Then the reward token tends to be below. So we're going to be sending this contract or the supply. So let's try to claim. Let's see. Try to claim. We're going to copy the claim fee. Then I'll copy the claim fee. We'll input it here. Okay. Okay, claim was successful. So you check out the balance. We had 97. So we are going to test the withdraw function. Let's use another person to withdraw. Let's see if it's going to be working. So you can see through the error, not owner. So let's try to use the owner to withdraw. Only owner can withdraw. So let's try to withdraw. You can see our item was withdrawn successfully and it added to our balance 98. So our contract is fully working and functional. So this is how to do a simple hold to claim airdrop. So in our next video we are going to be testing this contract. We're going to be using a unit test to test this contract on we're going to be testing it on Foundry. So catch you in the next video.